Hello everyone. This is exactly what NASA's official Voyager account tweeted a few days back to celebrate Voyager 1's comeback. Finally, after 5 months of gibberish, NASA has received a message from interstellar space in a way that makes sense. Considering everything that has happened in the past 5 months, this is nothing short of a triumph to be celebrated. At 15 billion miles away, Voyager 1 holds the title of the farthest human-made object in space. The spacecraft has been traveling for nearly half a century now. However, due to a glitch that led to a chain of confusing communication patterns, the last 5 months have been very stressful in the spacecraft's history. NASA engineers working on the fix faced 2 serious challenges. First, the spacecraft was built more than 5 decades ago by people who have long since retired, so the present team needed to go very deep into the old documents to see how the probe and its computers worked. Secondly, the technology is highly outdated. Although several software updates have been carried out in recent decades. As a comparison, today, even the cell phone in your hand can handle more than 100 billion instructions a second. On the other hand, Voyager's computers can process just 8,000 a second. But what exactly was the glitch that took so long to fix? Why didn't the traditional strategy of turning it on and off work? Finally, and most importantly, is the issue completely resolved? Or is there something else that needs to be addressed? The Voyager spacecraft, just like computers on Earth, uses the binary system to communicate with us. It employs only 2 numbers, 0 and 1, representing all kinds of information. Each 0 or 1 is referred to as a bit, and a combination of these bits can represent anything from numbers and letters to more complex data like pictures or sounds. There are 3 main computers on board Voyager 1, and it has turned out that the glitch was linked to one of them, called the Flight Data System, or FDS. The FDS is responsible for collecting 2 types of information from the spacecraft: data from scientific instruments designed to study the universe, and data related to the spacecraft's own health, in indicating if all parts are working correctly or not. After collecting this information in binary format, the FDS processes and combines it into a single data package. This package is then sent to the second computer, the Computer Command System, containing the Telemetry Modulation Unit or the TMU, which transmits this package back to Earth. To do so, the binary data are first modulated onto a carrier signal for transmission to Earth. Once this is done, the TMU transmits the waves carrying the data received on Earth via the Deep Space Network, or the DSN. The DSN is a collection of large radio antennas strategically placed around the Earth, such as in California, Spain, and Australia, to ensure continuous communication with different spacecraft as the planet rotates. Once the binary data are received, they are further processed in data centers. The binary data are converted into human-readable formats like numerical values, graphs, or images that are further used for analysis and research. Since the spacecraft was launched, it has been sharing information this way. But for the last few months, instead of sending the usual mix of scientific information and spacecraft health data, the TMU was sending a strange and repetitive sequence of 1s and 0s that didn't make any sense. For some reason, the FDS wasn't handling the information correctly. Since a piece of incorrect information was reaching the TMU from FDS, the TMU was transmitting irrational binary messages back to Earth. Usually, when such a problem arises, the first solution is to restart the FDS by turning it off and back on again. This approach often fixes most technological problems here on Earth and even in space. For example, back in 2010, when Voyager 2's data showed a similar issue due to a flip in one of the bits, the team performed a resetting command for the memory of the FDS, which successfully resolved the issue. This on-off mechanism even solved a glitch faced by the Hubble Space Telescope a couple of years ago. Following the same strategy, a reset was also performed on the FDS this time, but that didn't help. The problem persisted when the system was turned back on. This prompted engineers and scientists to devise more robust solutions. The Voyager team achieved a breakthrough after months of meticulous troubleshooting. They finally identified that a faulty chip was the root cause of all their problems. But how did they come to know about it? In March 2024, the mission team sent a so-called poke command to the FDS. A poke command is a direct way to modify the values stored at specific memory addresses of a computer. This is typically directly used for performing low-level operations, mostly in older computer systems. Using poke, a programmer can directly interact with the system's hardware by changing values stored in its memory.